So I got bored these days and I decided to start reviewing my math. And I also like animation, so why not do like a video kind of thing? So, quick self introduction, I'm an 8th grader, king of bobs, and kinda an animator. Kinda. And so this channel is about math, and this video is about axisymmetry slash axisymmetric. And this is lesson 1 of probably 3. So, this brings the question, what is axisymmetry slash axisymmetric? Well, basically, it's axis plus symmetry. It's pretty simple. Now, these are examples of axisymmetric shapes. So, now we know axisymmetry means a shape when it can be folded along a line and the two sides match up. But does it mean shapes only? Nope. So you see, an angle can also be asymmetrical. We call the line that splits the angle in half the angle bisector. Makes sense, huh? Okay, now on to the examples. First question, what does triangle XYZ equal? So we know right now that AB is the perpendicular bisector of line XZ, and we know that XB equals 3 and triangle XYA equals 13. So since we know that AB perpendicularly bisects XZ, we know that XB equals ZB and XA equals ZA. We know that XB equals ZB and ZB equals 3, which means XB also equals 3. That way XZ equals 2 times 3, which is 6. We also know that XA equals AZ, which means we can replace the XA in triangle XYA to AZ, thus resulting XY plus YZ equaling 13. 13 plus 6 will equal triangle XYZ, which means triangle XYZ equals 19. So on to question 2. The question is, does AD perpendicularly bisect EF? So right now we know that AD is angle CVA's angle bisector, and we know that DE and DF are the height of AB and AC. To make AD perpendicularly bisect EF, AF and AE must be the same, and DF and DE must be the same. Since DE and DF are heights of AB and CA, that means that angle DFC and angle DEB equals 90 degrees. So next we're going to prove that AF equals AE and then DF equals DE. This is going to be a little bit more harder to prove, but once the concept is clear, it'll be pretty easy. Basically, if AF equals AE and DF equals DE, that means that triangle AFD and triangle AED are the same, or congruent. So if we can prove that triangle AFD is congruent to triangle AED, then we can get AF equals AE and DF equals DE. So here's how to prove how AD is the perpendicular bisector of FE. So first of all, we know that FAD equals EAD because line AD is angle FAE's angle bisector. We also know that AED equals AFD because they both equal 90 degrees. Since those two angles are the same, that means the last two angles, FDA and EDA, are the same because all of the angles of any triangle adds up to 180. If those two are equal, then the last two must be equal. And we know that AD equals AD, so if we use the ASA method right now, we can prove that triangle AFD and AED are congruent. And for those of you who don't know the ASA method, it's angle side angle. So since ADF is congruent to ADE, we know that the height of those two triangles are also the same, and the height is exactly where AD crosses. Therefore, AD perpendicularly bisects FE. Quick lesson number 2. So this is like a 20-second lesson about how to make an asymmetrical shape about another shape on the coordinate plane. So say we want to make an asymmetrical shape about triangle XYZ. To do it about the y-axis, just make all the x-coordinates negative. So for example, point X is coordinate AB. If you make an asymmetrical shape, it's going to be negative AB. It's the same deal if you make it about the x-axis, but instead of making the x coordinates negative, make the y coordinates negative.